So in order to account for the observed behavior of gases, a model was proposed which takes into account molecular concept as well as the kinetic concept of gas molecules. And this model was known as kinetic molecular theory of gases. And it is also known as microscopic model because its assumptions relate to microscopic particles like atoms or molecules present in gases. And this theory was put forward by Bernoulli. And that's Bernoulli. It was put forward by Bernoulli, and later it was upgraded by other guys like Maxwell and Boltzmann and everyone else. All right. So the one who proposed this theory is Bernoulli. And there are quite a lot of postulates about kinetic theory of gases. One of the main postulates, or the first postulate, is that it says gas is made up of quite a lot of minute discrete particles called molecules. So a gas is made up of gas molecules, and these molecules, the shape, size, and probably the mass of these molecules, they vary according to the gas. The second postulate is that the gaseous molecules are in constant random motion in all possible directions. Constant random motion, and during their motion the gaseous molecules collide on the wall of the container and also with other molecules elastically. Constant random motion. So that's it. Let me just write it. Constant random motion. And as I already said, the collision of the gas molecules is perfectly elastic in nature, and that means there's no loss of kinetic energy. Alright, so when the gas molecules they collide, they don't lose any energy. Oh hey, they just say and they just go away. So that's elastic, perfectly elastic collision between the gas molecules, and there's no loss of COLLISION. Alright, okay, and there's no effect of gravity on the gaseous molecules, and since there is no action of gravity, these molecules they just roam around everywhere. They fill up all empty spaces and they fly everywhere. That's why the gas molecules are found everywhere. They are not attracted by gravity. So gravity just says, oh hey there guys, you can just go away. All right, no need to come to me. And then that's gravity. No effect of gravity on the gaseous molecules. And one of the most important things is that the molecules, there's no any intermolecular force of attraction between the gaseous molecules, as in solids or liquids. So the molecules, they just stay in a container. They don't attract each other, or nor do they interact with each other. So there's no force of attraction between the gaseous molecules, and they don't interact with each other as well. No force of attraction between the molecules. All right, gravity also doesn't attract these molecules, and neither the molecules they do attract each other. Now let's move to the fifth one, and that's gaseous pressure is created due to the continuous bombardment of gaseous molecules on the wall of the container. So that's bombardment. They just hit the wall of the container in which they are kept, and the container experiences gaseous pressure. And you guys probably know that pressure increases with volume decreases with the increase in pressure. So we'll talk about that later in Charles' law. And the volume of gaseous molecules, it's way too small compared to the actual volume occupied by the gas. So volume of gaseous molecules is way too small. All right, they don't take up much space. Just a single molecule, I'm talking about a single molecule. So a single molecule does not take up a lot of space, but if we take in consideration the whole gas, then it takes up a lot of space, and that's volume is negligible. Volume is negligible. Sorry about my handwriting. And the final postulate, and this postulate is about the kinetic energy possessed by the gaseous molecules. The gaseous molecules, they are moving everywhere, so they got kinetic energy, and their kinetic energy is directly proportional to their absolute temperature. So these are the postulates of the kinetic theory of gases, and that's it.